Okay, so the fundamental theorem of algebra is something that you will need to be able to write out. The gist of it is that the number of zeros is equal to the degree of the polynomial. And then the official definition is if a polynomial has degree n, there are n total zeros, which includes real zeros, imaginary zeros, and so you are going to have to write, it'll say, explain what the fundamental theorem of algebra tells us. And then you will write a beautiful definition. Okay, so if a polynomial has degree n, there are n total zeros. That includes real zeros, imaginary zeros, and multiplicities. Okay, the next thing that we did was finding the possible roots. So I highlighted possible because you do not have to find the actual roots. When you're finding the possible roots, it's the factors of the constant on top, factors of the leading coefficient on the bottom, and then you do have to divide. So everything divided by 1 is here. Then I started dividing everything by 5. Then I divided by 25. If I have a repeat, you don't have to write it out twice. Okay, for example, 5 over 5 is 1, so I didn't need to write that out twice. 5 over 25 is 1/5. I don't need to write that out twice. B, it says, name 2 roots that are not possible. So you can pick any number that is not on the list in part A. Okay, so 2 that are not possible, just 2 that are not on the list of possible roots. Okay? So make sure that you know what's possible, what's not possible. All right, where are the real roots found on a graph? Real roots are the x-intercepts, so they're found on the x-axis. Imaginary roots cannot be found on the graph. How do we find imaginary roots? How do we have to find them? Yeah, we use the quadratic formula. Okay, and in some cases you can solve, but yeah, we've been finding them with the quadratic formula. Okay, and then the next one says if a polynomial has roots with a multiplicity, what would the graph look like? Draw 2 examples. And I know it's been a little bit since we've done multiplicities. And we've done some other things with even and odd. If it is an even multiplicity, the graph is going to touch the x-axis, but it's not going to go through it. Remember we called that a touchback? It really looks like what type of graph? If I cover part of it up. Yeah, it looks like a parabola. It has that soft curve there. Okay? And that would be an even multiplicity, not the degree. We do talk about even degrees. We're going to do that later today during that review. But this means it's an even multiplicity. So a multiplicity of 2, 4. A multiplicity is just the number of times something is a 0. So it counts multiple times. If the multiplicity is odd, then we know that the graph is going to bend through it. So like a cubic function, and it's going to bend through the x-axis as it crosses. And then if it goes straight through the x-axis, you're going to represent that as 1 root. And then I'm going to let you look at my examples for this one. And then yours do not have to be the exact same for some of these. So we can go over some different cases. Okay, so for part A, really for part A, you do have to have something that either looks like this or it's reflection. So if the multiplicity is 3, that means there's going to be a bend. And then because the root is 5, it has to bend at x equals 5. So it has to go through the x-axis. The degree is 3, so you can also think of it as, it's an odd degree. The ends go in opposite directions. Okay, so that has to happen. If it is degree 4, we know the ends go in the same direction, right? And then it's going to touch the x-axis, but it doesn't cross. Okay. Also, if you have a degree of 4, you'll notice that there are 3 turning points in the graph. Okay. And you'll see that happen sometimes. But each root has a multiplicity of 2, so you need 2 touchbacks. Okay. Doesn't matter where they are, you just need 2 of the touching the x-axis but not crossing. Okay.
And then for part C, which I think that one says part B on yours, there are a total of 4 zeros. So the ends are going to go in the same direction. One root has an odd multiplicity. So if it has an odd multiplicity and there are 4 total zeros, this has to be 3 zeros here. So if this is 3 zeros, it can only cross one more time and count as 1 zero to be a total of 4. Okay, so the multiplicities have shown us if there are 4 total zeros, it doesn't have to cross 4 times, it just has to have a bend or a touchback. Mm-hmm. Yeah, yep, that's fine. Yep. So this is just one example. Yep. You should just have a bend and then another that just goes straight through. And then for the degree 3, the ends are going in opposite directions. One root is -2, so it has to touch at -2. And because it's a multiplicity of 2, it's going to touch at -2 and then go back up, or it could go back down. So you could have the reflection of this as well. Okay, and that is all you have on that page. Okay, so what questions do you have like on the multiplicity or any of that? We're good?